The keyword for what's the word, guys? Say it again. What's the keyword? Proportions. It's like, guys, what show from our childhood had like keywords and they would all shout it out? Oh no, this is way past your time. Pee-wee's Playhouse. You did not watch that. They always, you did? They had the keywords, remember? And Cherry, the chair, would like shout it really loud. No? Do you remember that? So proportions. That's our keyword for today. You can shout it if you want to. Proportions. We've used proportions throughout this whole chapter. This one is a tiny bit of a different setup, but I'm pretty sure you'll pick it up pretty dang quick. Keep saying pretty. Here we go. The first parts are theorems. So write them down, and then let's make sure you're understanding what you're writing down. There's two triangles. But what theorem 8.4 is saying, you can now break it up. If you know you have two triangles, like we've got this purple one and this red one, if you know, when you're looking at these two triangles, that the two sides are parallel, then you can shortcut the proportions. That's what we're doing today. They're saying you can take this piece and put it over this piece. It's always going to be proportional to this piece over this piece. You can break up the triangles. As long as those two sides are parallel. Only if they're parallel though, yeah. Okay, and then this one is just the converse, flipping back. If you know they're proportional, then you can say, yes, these would have to be parallel right here. Let's apply it. So we've got this there, but let's see how it's used. So this next, here we go. What is the length of NR? So let's put a variable right here. X right there. Okay, check. Are there parallels in there? Okay, so if this is parallel to this, then we can split these up. Go one side at a time. So put 9 over X. That's going to be proportional to the other side. Now, since I started at 9, come down right here. Do this 6 over 4. Okay, I hear calculators opening, but I bet you can do it without a calculator. Are you ready? Cross multiply. What's 9 times 4? Perfect. Divide by the left arrow. What's 36 divided by 6? 6. That's it, guys. Final answer. X equals 6. All right, our very first example, how many are like, yeah, I got it. Does that make sense to you? Okay, we'll have more examples. So when it gets a little bit hairy, we'll go over it. Okay, this one. Same thing. It says find the length of DF. Let's put our variable there. And then go one entire side at a time and break it into pieces. So right here, these are parallel. So we know that we can break this piece into this piece, make a ratio. And then we can fill in the proportion with this piece over this piece. 12 over 8. All right, let's try this without a calculator. Do you know your 12 times tables? All right, I can go to 5 because 12 times 5 is a clock. It's 60. So then add another 12. All right, so 72. But does 8 go into 72? How many times? No, we're good. Mental math, look at us. All right, number 2. Number 2 is asking you if they're parallel. So we've got to see if they are. So break it into pieces, and then we can either check similar fractions, if they're the same fraction, or if they're the same decimal. So this piece over this piece, 42 over 54. We've got to see if that literally is equal to 36 over 48. Okay, I'm curious. How many of you are going to simplify the fractions? Some of you? How many are going to just change them in decimals? All right, go for it. Take your time and we'll get both answers. Do whatever you like best. I kind of want to take advantage of the fraction people. Did anybody simplify the fractions and then compare? Okay, Abigail, can you talk us through what you did? This one right here, 4254 simplifies to 7/9. Okay. Three-fourths. All right, just looking at those fractions, are those the same thing? So are those two going to be parallel? All right, right there. Now I'm going to teach you something cool. That will come in handy for the rest of your math lives, which is forever. All right, so right here I'm going to teach you a trick. But if you've had me before, you might have seen this trick because I try to teach all my students this. First off, this fraction, 3/4, you should just memorize that one. It's going to come up forever. What's the decimal? Okay, perfect. So that one, just memorize it. So that's 0.75. this one, does anybody know the trick when the denominator is 9? Ellie, you remember? All right, hold on. Let's let them discover it. Okay, so 7 over 9, something's going to happen. So 7/9, that's a division problem. Nod your head, so you agree. Type it in your calculator then. Do 7 divided by 9. Wow.
7.
Uh-huh. What's repeating?
7.
Conveniently, the 7. So this is 0.7, like Ali said with bar notation. So from there, we could say no. However, I want to teach you something about denominator of 9. All right, type in 1/9. Do 1 divided by 9. What's going to happen? Uh-huh. So the 1 repeats. The numerator always repeats. So without your calculators, what's 4/9 as a decimal?
0.9.
Exactly. So now you know. So you can shortcut those really fast. All right, I want to stretch you a little bit. How could you make a double repetition, like 0.23232323? What do you think?
Isn't it like we're 2, 3? Wouldn't it be put the line over both 2 and 3?
Put the line over both 2 and 3. Yes. So that'd be bar notation. So this. How can you go from that to a fraction though?
23
Over 100. Type it in. Do 23 divided by 100. Is the 100 what makes it repeat? You've got to get it to repeat. All right, I heard both. I heard 23 over 9. Try that one. Is that going to make the 2, 3 repeat? Logically, without a calculator, would it make it repeat?
No.
Okay, Gator, what are you trying to say? Try this. Will that make the 2, 3 repeat? Cool, right? All right, Allie, are you ready? I'll put you on the spot. How could we change 0.675 bar notation to a fraction?
675
Okay, test her out. Do you believe her? 675 divided by 999. Does it repeat? 675, 675, 675.
Oh yeah, it does.
Check it. You'll probably go over that in algebra too, but now you know the trick. If you ever are in like a rush situation, like a math test where no calculators, there's a 9, always makes a repeat. It's pretty cool, yeah. All right,
Why does it matter?
I'll show you if you really want to know. It's an algorithm. Have you heard that word?
Yeah.
Some of you have heard algorithm. It's an algorithm. It's like an algebra problem that you can solve. All right. Here we go. Next 2 theorems, same as before. Write them down and let's make sure you understand what's going on in these 2. All right, here we go. So this top one, it's kind of like we just barely talked about, but without the triangles. You can still break it up into pieces. This is saying we now have 3 parallel lines. So right here we have our parallel symbols. If they're all parallel, you can still break it into chunks. So this piece over this piece is proportional to this piece over this piece. How many of you, logically, does that make sense? It's kind of like our triangles, just no longer triangles anymore. Okay, this one, a little bit tricky. So we've got this ray that's bisecting angle ACB. So that's not saying this piece is equal to this piece. It's bisecting the angle. The angles are congruent. So if the angles are congruent, split up this piece over this piece. And that's going to be proportional to this piece over this piece. That one we haven't seen before. Okay, can I tell you something before we have an example? All right, see how it started with 80 first? And 80 was right here. The numerator on the other side has to be the part that's touching 80. Again, make sure the numerators of both come from the same thing. They're touching each other, literally. Be careful with that. Okay, let's practice. Here we go. Oh, this is the very first one. So GH, let's put our variable here. Break it up into pieces. So let's put 28 over x. And make a proportion to this one over this one. 30 over 25. Okay, I would grab a calculator, type it in. So cross multiply 28 times 35 divided by 3. I'm trying to think if it's a whole number. Is it? No? On the board. So cross multiply 28 times 25 divided by 30. We got how many? Yeah? Okay, I have a question for you. Okay, we just barely learned this. Keep the whole number 23. What's this as a fraction if 3 is repeating? Allie, go ahead. 1/3. Wait, where'd she get 1/3? It's 3/9, but Allie simplified, yeah? So fast. I will take either one, whatever you are most comfortable with. How many? I get that. Does that 3/9 make sense? And then simplify it 1/3. Convenient. Okay. This part. Oh, it's one of the tricky ones. What are we looking for? QR? Let's put an X where the QR is then. Okay, we need to break it into pieces. We've got the 12, we have the 8, we have this is X. What are we going to put for RS? We don't know what it is. We know the whole thing is 18, but we don't know specifically. Ellie, what do you think? Say it one more time.
18 minus
Guys, tell me what Ellie's saying.
18 minus
Do you think that would be okay to put in there? Oh yeah, totally. So this is like the questions we reviewed yesterday where you use distributive property. Alright. Now this is our setup. Landon is still with us. Let's do this piece over this piece. So 12 over 8. And make a proportion. Okay, now it matters. Is this going to be x over 18 minus x or 18 minus x over x? It matters. It's going to be the x first because 12 came first, and you've got to choose the side that's touching the 12. So x first, and then 18 minus x. Okay, again, these are like the problems we reviewed yesterday, so you take the time to solve this. Hint, distributive property. Show your work.
So I just distributed the X's and stuff. What is 12 times 18? What's this off?
We can help you. Tell us. Or tell him.
10.8.
10.8? Yeah? How many of you got the same thing? We good? Chris, thank you for volunteering. Appreciate it. Alright, let me see again. How many of you got 10.8? Sweet. Good job. Alright. This problem. I think they give us all the information we need. Let's just put it on the picture. So HL, they said, is 2.4. KM right here, 2.8. And MP, 4.9. Find LN. Alright, this is the very first thing we learned today. Go for it. Set it up. Use your calculators. Because you look great. Does anybody mind raising their hand and tell me what setup did you use for this one? What did you put over what equals what over what? Go ahead, Allie, think.
2.4 over x
Okay,
equals 2.8 over 4.9.
nice. How many of you did the exact same setup as Allie? Yeah, Kelly. Perfect. Mariah? Is it a whole number or a decimal? Decimal? Can you shout it out to me? What is it? 4.2? Oh, that was convenient. How many of you got 4.2? Cross multiply 2.4 times 4.9. Divide. Perfect. Okay, how about this one? Let's help each other and then we'll go loose. What are you going to put for this missing link? Yeah. Use 21 minus x right here. Be careful with the setup. Good luck. Will you check the setup I left on the board for you? Is this the correct setup? Is it all correct setup, I should say? Make sure that the numerators are literally, they have a common vertex, do they? Yep. We're good. Alright, so this would just be 12x equals 16 distributive property. I'm definitely going to need your help. Check out your notes. So that's 12x. What's 16 times 21? 336 minus 16x. Add 16x to both sides. That's 28x equals 336. So you're telling me when you divide by 28, you get 12? All right, how many of you have all those steps? Maybe even some more because I jumped a little bit. Perfect. Okay. This next part, this is actually a picture of your assignment. But I want to make sure you can handle this part because this lesson kind of assumes that you can do this, but in the notes it never goes over it. I'm pretty sure you can handle it, but I don't want to leave you hanging. So this first part, what I suggest you do, what I always suggest, is trace over stuff. So we've got AB, this one over this whole thing, AF. So that's going to be BC over what?
FG.
Yes, it is FG. What this section goes over is pieces, but it also goes over entire triangles. So they're talking about this blue triangle and this purple triangle. Do you see that? So they're saying one side from a little guy compared to one side from a big guy equals one side from a little guy, bigger side from the big guy. Yeah? Okay, let's maybe do another one. So don't forget that it does pieces of the triangles, but it also does entire sides of the triangle. I can't remember what other one was tricky. Let's just go right to number 2. So number 2 is BD over DF. Oh, I swear this is just today's. Something over EG. Guys, what is it? CE. So that's not one that uses triangles. That just uses pieces of the picture. Do you see the difference?